Hey everybody, today I wanted to go over a little bit about the basics of atomic structure as we progress into our studying of biology. So as usual, I'm going to go through some slides, talk about the details I think are important, and so let me get myself out of the way and we'll start talking. So again, we're going to think about the basics of atomic structure, and so let's set the ground there. So in biology, we're studying living things, right? So we're interested in animals and plants and other biological things. So we're studying living things. Why do we care about atomic structure? Well, it turns out if you zoom in on that living thing enough, right, we'll see that that living thing is made out of cells, right? So all living things are made out of cells. That's something we've talked about already. Okay. If we look closer at those cells, we'll find that all cells are made out of smaller things called molecules. So we're going to build these molecules. We'll talk about a lot of different molecules over the coming weeks and their functions. So we build those cells out of molecules. But if we look more closely at a molecule, all those molecules are made out of atoms, right? So for us to understand living things, we really have to understand atoms. We're going to take those atoms, we're going to put them together into molecules. We'll put the molecules together into cells, and then we'll finally put those cells together into the living organisms that we're talking about. So let's talk about those atoms and what they're made out of. Okay. Sorry. So another thing that we are interested in terms of atoms is that, again, living things are made out of these atoms. And it turns out that there's just 4 kinds of atoms that make up the vast majority of every single living thing. And those are oxygen, carbon, hydrogen, and nitrogen. Just those 4 kinds of atoms, elements as we call them, make up 96% of all living things. So again, if we want to understand how living things work, we need to understand how these atoms work. How the atoms oxygen, carbon, hydrogen, and nitrogen work together to make molecules, so we can put them together into cells, and then we can put those cells together into organisms. All right, so again, let's think about the structure of an atom. Atoms are pretty simple things. They're composed of just 3 subatomic particles. So the building blocks of atoms we call subatomic particles. And we're going to talk about the characteristics of each. So we're going to talk about protons, neutrons, and electrons. This diagram does a great job of showing the some basic characteristics of each one of these subatomic particles. And on the next slide, we'll talk about those more in depth. Okay. But as you can see, the atom has a particular structure. There's a couple locations. There's this nucleus here in the center, and then there are these electrons orbiting around the nucleus. We can see that, again, the electrons are orbiting around the nucleus, and the nucleus contains these protons and these neutrons. Okay. There's some more information here as well. So in the nucleus, we've got protons and neutrons. Protons have these little plus signs on them, indicating their charge. You'll notice the neutrons don't have any sign indicating their charge. And if you look really closely at the electrons, there's a little negative charge on there. So we're learning some stuff about where these subatomic particles are, and we've learned about what their charge is. The last thing I want to point out is the relative size. These electrons are relatively small, whereas protons and neutrons are relatively large, and they are about equal in size. And so we'll use that information on the next slide. All right, so it's important for us, again, to understand atoms so we can understand how to put together living things. And we make atoms out of these 3 subatomic particles. So let's organize the information we have about these subatomic particles. I like to do that in a table. All right, so here I have a table where we can add in the names of these different particles. We can add in the location where we find them inside an atom. We can add in their mass. What's their size? Okay. Mass comes in atomic mass units, AMUs, or Daltons. You might see those 2 units of mass used interchangeably. Next, we'll think about what their charge is. And then lastly, we'll consider what would happen to an atom if we added or removed any one of these particles to it. Right? And so we'll get to that last. All right, so let's build this table, right? And let's start with protons. So we saw protons on the last slide. They're one of these subatomic particles that we make atoms out of. If you remember from the last slide, we found those protons in the middle, in the nucleus. So protons are always found in the nucleus. You'll remember that on that slide, the last slide, the size of the proton was relatively large in comparison to the electron, but about equal to the neutron. That's indicative of its mass. We say that protons have a mass of 1. Again, 1 atomic mass unit or 1 Dalton. And again, those can be used interchangeably. Okay. So protons are in the nucleus. They have a mass of 1. And then they have a charge. So again, on the last slide, we saw that those proton balls were appended with a little positive sign. Protons have a positive charge. I find that really easy to remember. I look at the word proton, I think pro, positive, right? If we had a pro-con list, the pros are the positive things on there. Protons have a positive charge. I'm going to skip this last cell for now. We'll come back and fill that in later. But those are the important details that we always need to remember about protons. They're in the nucleus, they have a mass of 1, and they have a charge that is positive. So let's add information about a second subatomic particle. We'll do the neutrons next. So neutrons, they were also found in the nucleus with the protons. We'll remember that the neutrons and the protons were about the same size in that little diagram on the last slide. That's because they have the same mass. They both have a mass of 1 atomic mass unit or 1 Dalton. And then finally, we can think about the charge of the neutron. So again, I think the name is extremely informative here. Neutrons are neutral, right? It's right there at the beginning of the name, neutral, neutrons. Neutral things have no charge. So no charge here. And then again, we'll come back and fill in this last cell later on. Okay, so the last subatomic particle is the electron. It might be hidden behind my head there, but electrons are the last one we'll talk about. Electrons, you'll remember from the diagram, they weren't in the nucleus. We find electrons orbiting the nucleus. Those electrons, we'll consider their mass. If you remember back, they were much smaller than the protons and the neutrons. We say that electrons have no mass. Really, that's an oversimplification that we use in biology so that we don't get as confused. So for our purposes, we can assume that electrons have no mass. Again, that's a lie. They have a little bit of a tiny little bit of mass. That can be important in other areas of science. But for us biologists, it's okay for us to make the simplification that electrons lack mass. Okay. And so the last thing here is we should consider the charge of the electrons. This is where my little trick of using the name to give away the charge falls apart. Again, protons, pros are positives. Protons have a positive charge. Neutrons, neutral. Neutral things don't have a charge. Neutrons have no charge. Electrons, on the other hand, I would have named negatrons. That would have been much more informative to me. But instead, they did call them electrons. Electrons have a negative charge. So we have these 3 details about each of our subatomic particles. Again, we'll come back to this last column and fill in that little bit of information later. But let's look at all the different kinds of atoms that exist and how we can use this information. So here's a copy of a periodic table of the elements. I just grabbed one off of the internet. They're super easy to find, right? But they're all organized in the same way. They all have hydrogen up here in the upper left-hand corner. And then we go read across and we get to helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen. I'll remind you that it's these elements, hydrogen, carbon, nitrogen, and oxygen, that we are mostly made out of. So in biology, we're really concerned about these atoms that are near the top of the periodic table. Again, hydrogen, carbon, nitrogen, and oxygen. And in biology, we tend to only talk about these atoms in the top 3 rows of the periodic table. We tend not to think too much about these atoms in the bottom rows. So let's look at how this is organized, right? And we can use this iron cell. Fe is the abbreviation for the element iron. And we can look in this cell and figure out some things about the iron atom. So one of the things is, the most important perhaps, is the atomic number. If you look around the periodic table, you'll notice that every single element has a different atomic number. Okay? So we organize this periodic table by atomic number. Atomic number 1 is hydrogen, 2 is helium, 3 is lithium, 4 is beryllium. That atomic number tells us something. It tells us how many protons are in the nucleus of that atom. So we just learned something important. Each atom, each element is different from other elements because of the number of protons in the nucleus. So let's go back to our table here. Again, I have this question at the end. What happens if you add or remove one of these particles from an atom? So again, we're thinking about the proton. What happens if we add or remove a proton from our atom? Let's use a simple example. Let's start with hydrogen. So what happens if we add a proton to hydrogen? Now that nucleus is going to have 2 protons in it. Remember, the number of protons in the nucleus determine which element it is. We will have turned that hydrogen atom into a helium atom. So what we do is we change the element. If we add or remove a proton from an atom, we change the identity of the element. Cool, so let's go back to our periodic table, right? Again, if we added a proton to hydrogen, we would get helium, because helium has 2 protons. Hydrogen only has 1 proton. Okay, iron right here has 26 protons in its nucleus. All right, so what's the next detail that's important in this periodic table? It's right here. It's this number for iron, it's 55.845. That's the atomic mass. Okay. The atomic mass tells us something about the element. It tells us the weight, right? How much mass the element has. So which of the particles from the atom have mass? Remember, it's just the protons and the neutrons. So the difference, if we determine the mass of an atom, all we have to do is add together the number of protons and neutrons. So let's go back to our table and think about another question here, right? So what happens if you add or remove a neutron from the nucleus of an atom, right? So if I took an atom, let's say it's a carbon atom, and I put another neutron into the nucleus, I just made a carbon atom that weighs 1 unit more. I made a heavier carbon atom. And we have a term for that in science. So if I add or remove a neutron, I change the mass of the atom, and that's called making a different isotope. So there are carbon atoms that weigh different amounts, and those are referred to as different isotopes. All right. So the last thing I want to point out here is that atomic mass is not a round number. 55.845, it doesn't mean that iron contains 0.845 neutrons. It means that there are different iron atoms in the world. Some of them weigh 55, some of them weigh 56. And if we took the average weight for all the iron atoms, we get 55.845. All right. So the last thing we want to fill in here for the characteristics of our atoms is what happens if we add or remove an electron from our atom. So if we add or remove an electron, we are going to affect the charge of that atom. We're going to change the charge. If we add an electron, we're going to make it more negative. If we remove electrons, we're going to take away negative charges, leaving behind just these positive charges of the protons. And we're going to make it more positive. So if we add or remove electrons, we're going to change the charge of the atom, which will create an ion. So ions refer to charged atoms. Okay, so that's where we'll stop for now in terms of discussing basic atomic structure. And we'll move on in the future to talk about how we use that atomic structure to figure out how we can make molecules, connecting atoms together to make larger structures. So we'll pick that up later on, and let me know if you have any questions about this material.